housekeeping items before I turn it over to today's speakers. Today's webinar is being recorded, so a recording along with slides will be posted to our website in about 10 business days. I will be sending out an email once those are posted to our website, but I also encourage you to check back. Everyone is on mute today, so please submit your questions via the question box. I have an example here on this slide. So on your panel of GoToMeeting, there is a questions box. So if you can just submit your questions throughout the presentation, and we will cover those at the end of the presentations. We'll leave about 10 to 15 minutes for questions. Since there are multiple speakers today, please indicate who your question is for when submitting your question, just so we know who to ask that of at the end. Please check back to our website for future webinars. We do host these monthly, so I encourage you to definitely get on our website, and I also encourage you to sign up for our newsletter, which keeps you in the loop. We send it out monthly of what's going on in the world of hydrogen and fuel cells, and especially what's going on in our office. On that note, I'm going to turn it over to Jason Markonsky. He is the Fuel Cell Technology Manager for the Fuel Cells Technology Office, managing the Technology Validation Program. And on that note, Jason, I'm going to turn it over to you.
Thank you, Allie. Like Allie said, I'm Jason Markonsky. I manage the Technology Validation Program in the Fuel Cell Technologies Office. And today we have two presentations. I'm very thankful to have Marianne Mintz of Argonne National Laboratories and Sarah Williams from the CEC, California Energy Commission. Marianne will present second. Marianne is discussing new tools for estimating the economic impacts of hydrogen infrastructure for early market fuel cell electric vehicles. But first, we'll hear from Sarah Williams, who has worked at the Energy Commission since 2007. She's a member of the hydrogen team in the Emerging Fuels and Technologies Office. She has been instrumental in gathering, designing, and conducting the past two hydrogen refueling infrastructure solicitations for California. Sarah will discuss the funding process used to fund hydrogen refueling infrastructure in the California Energy Commission's Program Opportunity Notice on 13607, the recent solicitation which proposed 28 new stations for funding. The webinar will address the evaluation criteria, variety of competitions, and the information included in the notice of proposed awards. So with that, I'd like to welcome Sarah Williams to present.
All right, thank you, Jason. This is Sarah Williams, like you just said, and I'm going to be talking about our work trying to fund hydrogen fueling infrastructure in California. If you could go ahead and move on. Last summer, we launched an exhaustive effort to make sure that we understood the needs of all the stakeholders to ensure that we could properly support hydrogen fueling infrastructure. And so we had stakeholder interviews, we did several workshops, we released a draft for comments, and then finally released a solicitation. And if you could move on. Some of the things that we put into the solicitation were we had specific location areas identified but not required. We have the minimum of 33% renewable hydrogen because that's the law here. There was project incentives for early completion, and we wanted to make sure there wasn't any overlap, so we had the minimum of a 6-minute drive time between stations. And we had a 60% applicant cap to try and encourage multiple applicants. Could move on, and this is one of our sample station location areas, and just so you can see what it looks like. If you want to go on to the next slide. Our proposals were evaluated against scoring criteria. This is fairly standard for when the Energy Commission funds something, but we do articulate them. And then disqualifications were determined. We required they achieve 21 points, which was 70% on the qualification scoring criteria. We only funded one station per station location area. We only funded one station within a 6-minute drive time, and the 60% single applicant cap. And then funding recommendations were finalized. Could move on. These were our scoring criteria. I mentioned the qualification of the applicant team as one of them before. We were really focused this time on market viability. We also looked at project readiness, implementation, and budget, economic benefits, performance, and innovation and sustainability. And then we did have several competitions. If you could move on to the next slide. In the solicitation, our first step was to fund operation and maintenance for existing and planned stations. And we wanted to make sure we put that in front to make sure that we could support the stations that needed it. Then we had a competition for 100% renewable fueling stations. Then we wanted to have a mobile refueler so that we'd have a backup for if stations went down. Then we did stations that were within or assigned to station location areas, and then any stations that were outside of that area. So we went in that order to show priority of funding. We put funding limits on renewable hydrogen and mobile refuelers to highlight their importance but not use all of the funds for them. We could move on to the next slide. So operation and maintenance support grants, we're providing up to $100,000 per year for up to 3 years. This is for existing planned or newly proposed stations. All applications are expected to be awarded, and stations are incentivized for early operational dates. For the existing stations, I believe we have 4 agreements already underway on this, and as new stations become operational, we'll be funding them at that time. Next, we're looking at the 100% renewable support grants. If you could move on to the next slide. Oh, sorry, next we're moving. Yes. So these are required to dispense 100% renewable hydrogen, and they can do that with RECs or credits if necessary. The maximum funding per station was $3.15 million. We had a required match of 10%, and we awarded $2.9 million for 2 stations. So they came in at under the max funding, and we got to 100% renewable stations. We were excited about that. Then under mobile refuelers, this is, like I said, to provide backup for refueling to support the network. We required that it be deployed statewide. It can be used when not needed for backups to do fuel cell vehicle demonstrations and other events. The max funding was $1 million with a required match of 20%. And there was just under $1 million recommended for funding for 1 mobile refueler. So that should be on its way. If you want to look at station location area competition, that provides the capital expenses for station installation for stations that are within or assigned to the station location area. And the way we did that is, if you remember the map that I showed you a little bit ago, that was within the station location area. And then if they were outside that but within a 20-minute drive time, they were assigned to that station location area. The max funding here was $2.125 million, so a little bit less than 100% renewable, with a minimum match share of 15%. There were $40.5 million was recommended for funding for 25 stations. That includes 3 additional stations dispensing 100% renewable hydrogen. And we were really excited to see that because that's something we are always happy to support. In the unassigned station competition, funds were for stations that were not within the assigned station location areas. This funding was the same with the $2.125 million and 15% match. We did suggest for award $2.1 million for 1 station located in Ontario, California. And then here's our status. The notice of proposed awards was released May 1st. It recommended $46.6 million for 22 stations and 1 mobile refueler. The agreements are currently under development for approval, and you can find all of the details at the web link there. And then if you want to move on to the next slide, this is what we recommended for funding. First Element Fuels was proposed for 19 stations, 7 in the San Francisco Bay Area, 9 in the greater Los Angeles area, and a connector in or destination station in Truckee, Coalinga, and San Diego. HyGen Industries was proposed for funding for 3 stations in Roanoke Park, Pacific Palisades, and Orange. And Orange is in Southern California, but those other 2 are in Northern California. Linde was proposed for 2 stations in Oakland and San Ramon. That's Northern California again. And Air Liquide was proposed for 1 station in Palo Alto. And then we have Riverside, Woodside, Ontario, and the mobile refueler, which will cover the entire state. So we were excited both to see that many applicants and the variety of geographical coverage there. So just so that you're aware, this is the background we're coming from. The existing stations, we have 1 in Northern California. It's in Emeryville. AC Transit worked with Linde and did a renewable by electrolyzer station. It fuels both buses and light-duty vehicles. It's supplemented when necessary with commercially supplied hydrogen delivery by truck, and that's been working well. There are more stations existing in Southern California. We have Burbank, West Los Angeles, Torrance, Los Angeles Harbor City, Fountain Valley, UC Irvine, Newport Beach, and Thousand Palms. There are also a number of stations that have been funded but haven't yet become operational. These are the ones in Northern California. The West Sacramento station is expected in September. Then Mountain View, Foster City, and Cupertino are all expected next June. And I know West Sacramento, they've broken ground, so we're all excited about that because it's close to us. And then if we move on to the planned stations in and here's a map so that you can see where many of those stations are. It doesn't include the West Sacramento one because that's further to the east. But you can see they've got the green ones are the ones that are open. The blue ones are those that we were just talking about that are in development. And you can see the orange dots are the ones that we're proposing for funding this time. So that gives you a better idea if you're not as familiar with the California geography. And these are the planned stations in Southern California. I'm not going to read through all of these, but you can see there's a lot of them coming operational this year. The one in Diamond Bar is just about ready to have itself declared operational. I think they're expecting that to happen in the next couple of weeks. And the rest of them should be by the end of the year. So we're excited about that because that'll really build the network. And here's a map so that you can see where those are located with the same color scheme as before. And I believe that's the state of hydrogen refueling in California. And we're really looking forward to seeing the stations roll out.
Thank you very much, Sarah, for your presentation. We're going to hold questions until the end of both presentations. So now I would like to introduce Marianne Mintz, who leads the Deployment and Analysis team within Argonne's Energy Systems Division. She has over 30 years experience in transportation and energy analysis. Her current work centers on infrastructure requirements of alternative fuel pathways, hydrogen delivery, and economic impacts of fuel cells, as well as hydrogen and natural gas fueling infrastructure. Marianne will discuss a new tool for estimating the economic impacts of hydrogen infrastructure for early market fuel cell electric vehicles. The tool, titled Hydrogen Jobs H2, estimates the jobs, earnings, and economic output created by deploying hydrogen fueling stations. The webinar will include the model's approach and its capabilities, a discussion of default parameters and assumptions, results and sensitivities, and access to the tools and additional resources. Please welcome Marion Mintz.
Thank you, Jason, and thank you, Allie, for advancing the slides. Good morning or afternoon, everybody. This is a very nice pairing between the activities of California, where they're actually funding the stations, and our work, which is looking at some of the potential impacts and the reasons why these are a good thing to be doing. Today I'll be speaking on behalf of my colleagues, Jerry Gillette here at Argonne and Catherine Mertes and Eric Stewart at RCF. Basically, I'll talk for all of us, but as far as questions are concerned, if we end up having to respond via email, you may be hearing from one of these other fellows as well. I'd also like to acknowledge the support of the Fuel Cells Technology Office within DOE, and specifically Fred Josick and Greg Kleen, who have supported this work. Next slide, please. As Jason indicated in his introductory comments, we'll talk quickly about the Jobs H2 tool, its approach, some metrics, and some illustrative results and sensitivities. We'll also talk a little bit about user resources and next steps, and then allow some time for open discussion or Q&A, as Jason indicated. Next slide, please. Next slide, please. Okay, first of all, why do we have a Jobs H2? Why are we developing this model? Basically three reasons. To provide a consistent platform to analyze employment and other economic impacts of hydrogen infrastructure investments for early markets. Also to analyze specific fuel cell and infrastructure deployment strategies, scenarios, projects, and to provide input for DOE's R&D priorities. And I just want to emphasize that at this point we're only looking, when we talk about hydrogen infrastructure, the tool is only looking at stations and only certain kinds of stations. And by those kinds, I'm talking about how the hydrogen is delivered and delivered to the station, or, yeah, these are all delivery scenarios, and the capacity of the station. And then lastly, and very importantly, we developed this tool to support stakeholders in their efforts to develop and deploy stations. Next slide, please. So what is Jobs H2? It stands for Jobs and Economic Impacts of Hydrogen. It's a spreadsheet-based tool, Excel-based, to estimate economic impact of user-defined scenarios. And it does that by modeling the economic impacts via supply chains and induced effects, and I'll explain that in a moment. It can be run with default values or user inputs, and it uses a methodology to convert dollars spent into economic impacts that's based upon a publicly available input-output model developed by the U.S. Department of Commerce Bureau of Economic Analysis. And that model is called the Regional Input-Output Modeling System, or RIMS. And jobs are created from equipment production, installation, station construction, all of the things involved in getting the station up and running, and then from operating the station, as well as from ripple effects. And we call those ripple effects induced jobs. And the next figure, I think, will explain this a little bit better. It's kind of like a little cartoon. Next slide, please. Basically, when you think about a station, you think about the equipment that's actually on the ground. And here we're showing a little illustration of the three big components of a hydrogen station. You have compression, storage, and dispensing. And when you think about putting a hydrogen station in place, you think about the workers that are installing all of that equipment. But that's really only a very small piece of the whole. Next slide, please. First of all, when we talk about that small piece, though, I just want to introduce a couple of other concepts. Those workers, they have wages, they earn wages, which we call earnings. They also add to the overall economy in the form of economic output. And so when we model the impact of the station equipment that's actually on site, we model both. We model the workers, the output, and the earnings, all three of them. And then as we move up the supply chain, we also look at all of the various activities that are required to get that station up and running. So there's a lot of planning. The station has to be designed. There's survey work. There's permitting. There's all kinds of preparatory work, and we call that the station planning supply chain. Next slide, please. We also have a construction supply chain. So we have a management activity, and we have equipment that's on site, and it's bringing materials, concrete or whatever, to the site and doing all the site prep and the pre-installation work. And all of those activities, the station planning, the construction, and as we move up the station equipment supply chain, all of those require employment. Those employees earn wages, and they produce economic output. And the station equipment supply chain, I'd like to just emphasize the fact that it's not just the production of the equipment, but it's also the integration, the transportation of the equipment to the site, it's the planning, it's all the fabrication and the materials that go into that equipment. So we're trying to capture all of that. And then once the station is actually up and running, we have a hydrogen supply chain at the bottom. And that's in this case, we're talking about tube trailers that deliver the hydrogen to the station, and that hydrogen is produced and it's transported, and all of those involve employment, workers, earnings, and output. And then we also have expenses to operate and run, next slide please, operate and run the station, and that we call that the station O&M supply chain. Now all of those, we can group them into overall supply chains. You can see these arrows going up through each of those on both sides. There's one on the right and on the left. And then lastly, I just want to make the point that they create jobs not just on site, but also from some ripple effects. So each of those workers go out and spend their dollars that they earn on different things. They may go on vacation, out to dinner, whatever. But those are ripple or induced effects, and we include those as well. Okay, next slide, please. Another aspect of the model was to permit regional analysis. And we do that by permitting the user to look at 60 different geographies. Those are any one of the 50 states, the 9 census regions, or the U.S. as a whole. And for each of those geographies, there are different multipliers in the RIMS input-output model. And so the user, when they pick a geography, the model will automatically provide the correct multipliers. Another very important concept that we use is what we call in-region or local shares of expenditures, so that we can account for the fact of whether or not that those dollars are being spent within the particular region that's being analyzed, or whether they go outside the region. Clearly, if you spend more of those dollars inside a particular region, you will have greater impacts in that region. If they go outside, if they leak into other regions, then you won't be capturing them in your estimates. And local shares tend to be greatest for things that involve site labor, like site prep or installation, retailing. Those things you're really not going to have people coming from outside your region to supply them. So they tend to have relatively high local shares, whereas some of the other aspects of station development that I mentioned earlier, like station design, engineering, and equipment production, those might have somewhat lower local shares. But the local shares are a user input. The user can assign whatever value they feel is most reasonable for the scenario that they're running. And we do have defaults, and I'll get into those in a moment. But basically, this is all user defined. And then there's a takeaway on the last part of the slide that jobs occur, next slide please, jobs occur where expenditures occur. And so if you have a high local share, as I said before, you'll have more jobs. Next slide please. This is a screen capture of the user interface for the station development tab in the model. I'm not going to actually demonstrate the model here today because we simply don't have enough time, but I'm going to try to give you a little bit of a sense of how it operates and refer you to resources that will enable you to download it and to see how it operates. Basically, this user interface, the user defines various things. If you look at the top, the value that's the default value for station size is 200 kilograms per day. The user can specify any value between 100 and 400 kilograms per day. So they put their value in the white cells where it says user specified value, and then it'll automatically be repeated in the gray cells as the value that's actually used in the model. So you can check to make sure that what you put in is actually what the model is going to run with. The next area, we have steps. Step 2 is the project development time frame. The value can be either 1 year or 2 years. The default is 2 years. In this case, the user didn't enter anything, so it automatically picks up 2 years. Step 3 requires a user input. There is no default. Step 3 are the number of new stations that you anticipate, you as the user, anticipate to be completed by the end of a given year. So in this case, we've entered 25 stations per year. The first set to be completed by the end of 2015, meaning that they were developed over 2014 and 2015, because there was a 2-year time frame that we specified up above for the development time. So that means that at the end of 2015, we will have 25 stations. At the end of 2016, we will have another 25 stations developed, not necessarily operating yet, but developed. And if you look at the default dollars per station, it's quite similar to the numbers that Sarah mentioned earlier in California. It's a little over $2 million per station. Now, if you go down to the next set, step 4A, you'll see the default assumptions for some of the components. And if I were able to copy the entire sheet here, you'd see additional ones as well. These are the default values that are in the model that add up to the $2.1 million, $2,145,000 that you see up above. And as I said earlier, the user can override any of those numbers and put in their own values. So if they feel that the dispenser one dispenser is not going to be adequate, they need 2. There's another tab for that, but they would put that in, and they might disagree with the price, and they'll put a different number in, and that's fine. The user will take whatever they put in. Next slide, please. So with those assumptions, the 25 stations per year, I'm just going to illustrate what happens when we run the model. If we assume a U.S. region, so this is for the U.S. as a whole, not any particular state or census region, and 200 kilogram per day stations, as I said earlier, we complete the first 25 stations in 2015, and then they begin operating the following year. That's why we go down to the next year for 2016 for stations in operation. Now, another parameter which was not shown in that particular portion that I just showed you of this green capture is station utilization. And that's the percent that the station is operating based upon what its theoretical capacity is. So we start off at 10%, this is a user input, and we increase it up to 70% in this particular scenario. The user can enter anything they wish. In that case, I believe the defaults are 50%. The local share of expenditures, when we're talking the U.S. as a whole, we have a higher local share because the U.S. basically would include equipment and everything else that's manufactured or installed or whatever from workers who reside in any state. The only thing that would not be captured were components that are imported from overseas. And in this particular scenario, the only component that we assume comes from overseas is the nozzle, which is a fairly small piece of the total. We assume a retail price of $14.50, which is basically, if you add the blue and the red together, that's what delivered cost of the hydrogen that comes to the station in that tube trailer costs. It's $6.50. And then these on-site expenditures are about $8, and that's for the overhead and margin. It's also for the O&M, the operation and maintenance of all the equipment at the station. So if you take those assumptions on the number of stations and how much fuel is being dispensed, then these are all inputs. The resulting hydrogen fuel sales ends up being a little under 8 million kilograms per year. That's the graph on the left. And the total station expenditures, the pie chart on the right, of that $2.1 million, which I've mentioned earlier, this is how it breaks down to all of the various pieces of equipment. You see the compressor is the biggest piece, 26.5%. Installation is also quite expensive, and the on-site storage, the cascade system, is relatively expensive as well. And again, these are the inputs to the model. In the next slide, I'll show the results. Next slide, please. So here on the first graph on the top, we show the number of stations in operation, just to refresh your memory. We start with 25 in 2016. These are the year after they're completed, they go into operation. We go up to 150 by 2021. The number of jobs that are associated with those stations It's a constant. It's about 1,000 jobs per year because we're always developing 25 stations up until 2020 when we kind of trails off because we stop. The total jobs peak at about 2,400, and that's in 2020 when the last stations begin operation. We're still doing a little bit of station development at that point, and so it drops a little bit in 2021 when we're only operating. If you go down and you look at the second set, it's basically the same graph, but here I'm focusing on the distribution between supply chain and induced jobs, whereas the top one focused on the difference between station development and station operations jobs. So the second slide, if you look at the bottom part, you see that induced jobs are about 40% of the total in most years. So they're a very significant piece, and it's important that we capture that as well when we're doing this kind of modeling. Next slide, please. I'm not going to spend much time on this slide. This is the earnings and output associated with that same number of stations. It follows a similar pattern, but the dollars associated, these are dollars instead of jobs. The dollars are a little bit different. Next slide, please. Now, we've also looked at sensitivities, and just to talk about our base case, and I have to emphasize here that this is not exactly the same as the scenario I just talked about. In our base case, we picked a middle scenario. We picked 100 stations, whereas before we were growing over time to 150. There's still 200 kilograms per day, but we looked at a particular region. In this case, we looked at Census Region 5, South Atlantic. So we have fewer, like I said, middle scenario, fewer stations, different region and years of operation than in our illustrative scenario. In that base case, if you look at the box on the top, we estimate a little over 2,000 jobs. We assume a local share of 100% for installation and site prep, 50% for the equipment and contingencies, design and engineering. Again, 200 kilograms per day for the station size, and the station costs we kept the same, $2.1 million. Now, for the sensitivity analysis, we varied those parameters. This first graph here talks only about station development jobs, which is the planning and getting all the equipment installed actually before we begin operation. Those station development jobs tend to be shorter duration. They basically end once everything is built, 1 to 2 years. They're involved, as I said, planning, construction, equipment production, installation, and we also do include the induced portion as well as the supply chain portion. And if you look at the, this is called a tornado chart. If you look at the tornado chart, at the bottom portion, you see the results are less sensitive to station size because there's not as much variation there. You still need to have a compressor. You still need to have actually the same cascade system. So a lot of your expenses are going to be not that much less for the smaller size station than for a larger size station. So we don't see as much variation in jobs. The vertical line is, just mentioned, that's around that 2,080 jobs that is referred to in the box up above in the base case. So you see a little bit of variation with station size. You see much more variation with local share for all of the various parameters that I mentioned before, for the equipment and all of the site prep, contingencies, everything. There you vary it from we varied it from 100% to 0%, and the base case is a combination of the two, which we show up above. You see at the low end we end up with about 1,000 jobs instead of the 2,080. At the high end we end up with over 3,000 jobs. Even more significant is station cost. We end up with more expensive stations, simply put more dollars into the economy. They require more spending on equipment, and mainly the equipment, but everything. And therefore that has a bigger induced effect as well. So if you have more expensive stations, you can create over 4,000 jobs. If you have less expensive stations, you're down at about 1,000. Base case, again, I said 2080. And then at the highest end, if we include both variations in local share and in station costs, we can get much larger impacts. And so you see on the positive side, If stations are more costly with high local share, they produce more jobs. If they're less costly with no local share, they produce less jobs. I think we've covered everything. Next slide, please. Now, looking at the station operation jobs in the same way, again, we have a tornado chart. It's the same base case, but here the station operation jobs are a bit less. They're a little under 700. And these are the jobs associated with producing and bringing the hydrogen to the station and operating and maintaining the station, dispensing the fuel, all of the stuff that basically happens once the station is in operation. These jobs tend to be multi-year duration, and they continue beyond the particular scenario that we're talking about. In the earlier slides, I forgot to mention the fact that beyond the last year shown in those graphs, the number of station operation jobs continues at the same level because we assume those stations continue to operate and they continue to have the same expenses and require the same maintenance and all of the various things that are required to keep that station operating. These station operation jobs, basically the higher the throughput and the higher the local share, they put more dollars into the local economy and they create more jobs. So as you move up the tornado chart, local share by itself is not as significant because we have a fair amount of local share already in the base case. We basically assumed that for retail expenses and O&M, we were already at 100% from some of those pieces. Station utilization has a big effect. If you get up to 80% utilization, you create many more jobs than 20% utilization. And recall again, our utilization is 50% in this base case. The station size, as I said before, now here it matters because you're putting more hydrogen through the station, and the hydrogen has various impacts going up their supply chain, and those create more jobs. So for the station operation, station size matters quite a bit. If you combine local share and station utilization, you get even more of an impact, or combining local share and station size. It's kind of similar levels. You end up at well over 1,000 jobs if you're on the high end, and only 300 or so jobs on the low end. Next slide, please. Now, I want to talk a little bit about the user resources. As I said earlier, I'm not doing a demonstration of the model here, so therefore I want to refer you to where you can see more of a demonstration type of thing. We have several reports and we have documentation which are on our website. We have a prior model which was called Jobs FC. It's the same jobs and economic output of fuel cells instead of hydrogen. That model has a user's guide. It has a documentation report. We did an analysis of the impact of the Recovery Act on jobs, and that was the deployment of fuel cells and backup power and forklifts. And we did an EERE webinar like the one today, and that link that you see there is the link to the recording of that webinar on the EERE website. Now, for today, we do have a report on the methodology in the Jobs H2 model, and that's mentioned here, and that is the first image that you see shown at those reports. And we have today's webinar, and we will be posting a link to the recording once that becomes available. And as Ali indicated earlier, it'll be in several days. Now, I just want to mention that we had an earlier website which was called jobsfc.es.anl.gov. That has now been linked to a new website. It still works, but it's been linked to a new website which is called jobsmodels.es.anl.gov. And all of this material is on that new website. It went live today. Next slide, please. One thing I want to show you is a screen capture of that part of that website. This is the homepage, which just talks about the jobs models in general. There are links at the left. We also have another link which is not shown in this particular slide called User Resources, and also the two models are separately identified. But if you go to that website, as I said, jobsfc.es.anl.gov, you will see all of this. Next slide, please. Now, there is one link on there called User Resources, and the User Resources includes, as I said earlier, user guides. And I just want to mention that for the H2 model, we went from the paper format, the print format, to a video format. We have 5 videos that are posted. They're short 5-minute videos which demonstrate different aspects of how to use the model. And that's part of the reason why we're not doing the demonstration here today. We also have the link to the publications and presentations, as I said before, the webinar presentations and the links. Next slide, please. Next steps. We're continuing to work on the development of the model and using it for various analyses. We will be looking at a rollout analysis in the next, over the summer, next few months, due by the end of September. We'll also be looking at liquid hydrogen delivery and larger stations. Next year, we plan to look at uncertainty analysis, which will be a big addition to the model. We have not started that work. That will be beginning this coming October. Another thing that we may be looking at next year, and it's listed under not funded, but it's in discussion at the moment, is distributed hydrogen production. I don't know if I emphasized it enough, but the current version of the model looks only at gaseous delivery of hydrogen via tube trailers, conventional tube trailers. We will be adding liquid delivery, and we would like to add production of hydrogen on site, what we call distributed hydrogen production. That would be next year. We would also like to look at novel station and pathway options and fuel cell applications in vehicles, which would be different from what we did before in the fuel cell model, because we were looking at very small fuel cells for forklifts and backup power. These would be much larger fuel cells for vehicles, and there would be bigger impacts through the supply chain, and we have not addressed that in this work. Next slide, please. I'd just like to quickly thank some of the stakeholders who have been very helpful to us in our work. They included representatives of public agencies, station developers, the hydrogen and fuel cell industry, fuel suppliers, and researchers. They provided help in developing the default values. And I'd just like to mention that the default value for our hydrogen station is very similar to the California Energy Commission's default, their value for the maximum funding amount. So we think we're talking to the same people, and we're getting good data. They also helped with our future directions and needs and in beta testing the model and validating it. The table on the lower left-hand side of the screen are some of the specific parameters that they provided input for. You can see in parens that's the actual default value in the model. You can see some values that are in a lighter shade. They're not in the model right now, but we're hoping to add them later. And all of these are based upon input from our advisory group, and we mentioned a few comments at the top. So we do want to thank them. Okay, next slide, please. Briefly to summarize that the jobs models, both the H2 model, which we're launching today, and the prior FC model, they provide consistent platforms for analyzing employment and economic impacts of alternative hydrogen and fuel cell investments. And Jobs H2, which is today's new launch, is a free downloadable spreadsheet model and is currently available on this website. Stakeholders have provided critical input and validation as we've developed these models, and we specifically thank DOE's Fuel Cell Technologies Office for their continued support, for our stakeholder advisory group for their assistance, and of course you for your attention. Thank you. And here's my contact.
So now we'll move into our question and answer period. We have a number of questions. I'll just take it from the top. The first question is, when are hydrogen fuel cell cars going to be sold or leased in the United States?
Hydrogen fuel cell cars can currently be leased in areas where there's fueling supported, and as more fueling rolls out and the new car models roll out, we expect to see more.
Okay, I'd like to add that there are a number of auto manufacturers that have made announcements and for plans to roll out fuel cell vehicles in the 2015 to 2020 timeframe. The next question is, so This is for Sarah, and this is regarding the mobile refueler. We'd like an example of how this type of system would be deployed to help explain what it is.
All right. And this is one where it's not something we've funded in the past, so we've left in the solicitation general enough that different applicants could propose different technologies. What it is generally is hydrogen storage and dispensing ability on some sort of mobile platform. I believe the GTI one that we proposed for funding is a large pickup. So it has capacity to hold the hydrogen. It can dispense directly to cars, or it can fill to a station if their reason for being down is a lack of supply. And it should have compression to deliver at least 350 bar, with hopefully 700.
Okay.
Does that answer?
Yeah, I think so. It's hard to get the feedback from the people writing the questions, so we'll just assume it does. Does California have statistics regarding use of completed stations? So I know NREL is collecting a lot of data. That's the National Renewable Energy Laboratory on existing stations through their prior work in the National Learning Demonstration and new work in data collection from the DOE. That will be on the next round, 9 additional stations. But right now, we're relying on the data from the learning demonstration.
Right. I know we have a good deal of information. The Air Resource Board does as well, because they funded some of the I think all of the currently existing stations. And as part of our grant agreements, we're requiring data collection, which would include throughput numbers.
Okay, this is another one for California, CC. Can these stations also be used by homes and small businesses? So I think just speak to the accessibility of these stations.
Absolutely. We require that all stations be publicly accessible. So even the picture I showed you of the AC Transit one, which is probably doing most of its throughput for buses, does have access for light-duty vehicles that are personally owned.
Okay. So this is for Marianne. I understand the DOE's regional analysis. Do the states of each region, California, Washington, Oregon, for example, both, 1, adhere to DOE's regional standards, if any, and 2, coordinate with the states in its region, for example, California, Washington, or Oregon? So this may be a bit outside scope, but I'll give you a chance to respond.
I'm not sure. Coordinate in their deployments of fuel cell electric vehicles? I'm not quite sure what the question is. I know that, well, we can certainly model activities. If a user, wishes to define a scenario for California or Oregon or Washington, they can run it for any individual state. What we cannot do in the model, this is just a model, is combine those 3 and create a separate region. We are confined to the census region that they reside in, which I believe is the Pacific census region, which I believe also includes Alaska and Hawaii. But most of it is those 3 states. But I'm not quite sure what the question is. I'm sorry.
Okay, that's fine. This one is for Sarah. So this is, what is the total cost for a hydrogen dispenser? And I assume this means the dispenser and the supporting equipment for an existing gas station seen in the recent solicitation. And this question is suggesting that California might be paying 90%. So could you speak to the cost share and what that covers?
So the cost share is slightly different depending on whether it's a 100% renewable station or a 33% renewable station or one within a 33% renewable network. For the renewable stations, we are providing 90%. That's for the 100% renewable, and because we know that those are generally more expensive. And then for the more standard stations, we are providing 85% share, so we require 10% or 15% depending on the station type. With that and the Energy Commission share being 2.125, we're expecting stations to be about 2.5 million.
Okay, can you tell us how many renewable stations have been awarded or proposed for award?
Absolutely. There were 2 stations proposed for awards under the actual 100% renewable competition. And then there are 3 stations that were proposed for awards outside of that competition that will be 100% renewable because that's just the business model for that particular applicant.
Okay. So the next, I guess I'll field the next question. What is the gasoline gas equivalent of hydrogen to the consumer? So I assume this means the 1 kilogram of hydrogen is equal to 1 gallon of gasoline on an energy basis. However, fuel cell vehicles are generally more efficient, up to twice as efficient as current gasoline vehicles. So, but on energy equivalence, it's 1 kilogram per 1 gallon. The next question is for Sarah. Are there any backup power requirements in case of grid failures for the stations?
We required that stations explain, or applicants explain what they would do for backups in their proposals. So there are a variety of different options. Many of the applicants did look at a lack of power. One of the things we looked at in mobile refuelers was the ability to work without power. And I believe that the one that we're proposing for funding actually has a fuel cell on it so that it can power itself with that, at least partially.
Okay. This is for Marianne. It seems the local share generated by a company building up to 17 stations will actually be less than expected because I think the company will rotate employees from one station to the next so as to minimize training expense, etc. So can you explain how this is accounted for in your model?
Yes. The station development expenses are short-term jobs. That's the point I made, and that's true. They can rotate employees. So we only talk about them as short-term jobs. And you notice when I present them, I distinguish between the 2 kinds. They could be held by different people, or they could be held by the same people. A company could rotate employees. That definitely happens, and that's always an issue when you're talking about jobs because we talk about a job for a year. Sometimes we use the word job year to account for that, and they are different duration jobs from the continued jobs to operate the station. That is an issue, and it's true of all employment numbers. When you talk about the government's jobs reports or whatever, they don't really go into that, but it's basically the same point. You can, as you create jobs, there may be a new job in 1 year, but then that person holds that job over multiple years, so it is confusing. But the way we've estimated them is the way that most people do.
Okay. Did the model factor in projected salaries as part of the induced spending or ripple effects? I'm curious about how operational jobs compare to standard oil-based infrastructure.
Well, that's all embedded in the input-output in the transactions matrix that's in the model. And so the oil and gas industry would have a different set of salary structure that might be different from the industrial gas sector, for example. So when we track the expenditures and we allocate them to different sectors, it picks up whatever the multipliers are in the model. So I can't tell you what they are, but it is captured in the input-output table because that's the way it's developed. They are different, and it would be captured.
Okay, this one's for Sarah. Is it better to site stations close together initially to give great coverage to a few people, or to spread them as widely as possible? So this sounds like kind of two extremes. So can you speak to how yours were spaced?
Absolutely. There's been, for several years now, this concept of clusters where we expect early adopters to be, so where the OEMs are targeting vehicle release as well as where we're targeting most of our building infrastructure. So as you may have noticed when we went through the locations, we've got a large core in the Los Angeles area where we expect there to be a lot of vehicles, and in the San Francisco Bay Area. So those are the places we expect the most initial adoption, and so we've focused there. But we do recognize the need for more complete coverage, and that's why we're starting to see some of the connector or destination stations. So we were excited to have the Coalinga station, even though it's not likely to be where a lot of hydrogen vehicle adopters are, because it allows for those drivers to move throughout the state. So yes, as we get more stations, it'll be important to get overall coverage, but to get things started, density where they're likely to be used was our goal.
Thank you. Marianne, does the Jobs H2 apply for a national model only, or can it work for state estimates as well?
Yes, it can. That was the point of the map that I showed. It can be run for any state, and the correct multipliers will be assigned. So you can do an analysis for the state of Arizona, Connecticut, California, whichever state you pick, or you can do a regional analysis using those the 9 census regions, or you can do a U.S. analysis.
Okay. Is there any companion research related to the environmental impacts associated with hydrogen fueling stations? The fueling stations themselves, not that I'm aware of, unless it's part of the station application process, and that would be a question for the local jurisdictions in California or wherever they're being developed. There's a lot of work that's gone into hydrogen production, including if it's on a distributed production. There's a lot of environmental analysis of that. And that would include greenhouse gas emissions, and I know that and criteria air pollutant emissions are estimated in a model called the GREET model. There's a California version of the GREET model. There's also a U.S. version that's here at the lab. So it's kind of a mixed bag. Parts of it are done. There's also water analysis of how much water is required for some of these things. So there's quite a bit of environmental analysis, but of the station itself, that would probably be, I would think, in California, it might be under the permitting process. Sarah?
Yes, it is definitely in part of our permitting process, but the AB 118 program, which is where our funding comes from, also requires that we do a localized health impacts report in which we look at the health impacts to the local area for any project that we're funding. And if anyone's interested, you can find all of those on our website, and I can send a link out if that would be useful. But we do look at the impacts of the construction as well as the possible increases of traffic due to the station.
Okay, I think we're out of time. Thank you, everyone, for your questions, and thank you to our presenters. Sorry we didn't get to all of the questions. Ali, is there a wrap-up?
Yes, thank you so much, Marianne and Sarah and Jason, for hosting this webinar. Just as a reminder, we have recorded today's webinar, so a recording along with slides will be posted to our website in about 10 business days, but I will send out an email as soon as those have posted. So thank you again, everyone, and definitely I encourage you to get back on our website and look for next month's webinar. Thanks, everyone.